All right, welcome back. Today we are taking a look at naming covalent compounds. So far we've done ionic compounds, we've done polyatomic ionic compounds, and today we take a look at covalent compounds. This is unit 7.3. And again, today we're looking at covalent compounds. These are also called molecules. So you've heard of like a molecule of water or a molecule of carbon dioxide. Molecules is a term that is specific to covalent compounds. We don't normally say a molecule of table salt, sodium chloride, because that's an ionic compound, and molecules, again, are specific to covalent compounds. All right, first of all, what they are. So hopefully a quick reminder from first semester, covalent compounds consist of two nonmetal elements, or a metalloid and a nonmetal. So again, hopefully we covered that first semester. If not, hey, that's why we're going over it again. Here's the stair-step line, and elements to the right of the stair-step line are nonmetals. So anything that has a metal in it, anything from this side of the periodic table, we should immediately identify as being an ionic compound, and it's not a covalent compound, and we're not going to follow these rules. But whenever you're working from two items on this side of the periodic table, this kind of top corner, we're not really going to work too much with the noble gases. They don't bond, so we can kind of forget about them. It's really just this handful of elements here, and hydrogen. Remember, he's a gas, so he's not a metal. He belongs in this group as well. When we work with those elements, it's a covalent molecule. So it'll be important that we notice and identify that first. Identify what you have, because the rules, you'll see in a second, the rules change a little bit. So for covalent compounds, we're going to use prefixes to indicate how many of each element is present. So again, a little bit different from ionic compounds where we use the charges and we had to balance based on charge. Now we're going to use prefixes to tell us how many there are. There is an exception. There always seems to be an exception. And that exception is the prefix mono is not used on the first element. So mono means one. We're going to use it for the second element if that's the case, but we don't use it for the first element. An example there, CO, one carbon, one oxygen. Because we don't use mono, we just say carbon, and then we will use mono for the second element, so carbon monoxide. There's our monoxide. One carbon, one oxygen. We just don't state the prefix mono on the first element. And then you're kind of noticing it here, and you've probably heard it before, like carbon dioxide. Just like in our ionic compounds, the second element ends in ide, I-D-E. So see that there? You hear it in carbon dioxide. You'll see it quite a bit this week. All right, without further ado, let's get to the prefixes. 1, hey, we just discussed 1. 1 is mono. Now with these prefixes, yes, you're going to need to learn them. You're going to need to study them a little bit. But here's the nice part. You probably already know a lot of them, if not most of them. So if you just focus on the ones that you don't know, you'll be in good shape and you'll learn them in no time flat. 2 is di. We used di a lot in biology last year, so hopefully you are familiar with di as 2. And if not, give it a look over a couple times, get familiar with it. 3, here's one everyone knows, tri. We use tri a ton, not just in chemistry, but in English as well. A triangle has 3 angles. A tricycle has 3 wheels. So tri should be really familiar to us. 4, you may or may not have heard of. 4 is tetra. 5, I'm quite certain we've all heard of, is penta. Like a pentagram. A pentagon has 6 sides. 6, you've probably heard of. Hexa. Hexagon has 6 sides. 7 may not be so familiar to you, so make sure you look that one over. Hepta is 7. 8, I bet you know already. Octa, like an octagon, has 8 sides. An octopus has 8 legs. That one's pretty familiar to us. 9 is nona, and the biggest we'll get, at least for now, 10, deca. Like a decade. A decade of years is 10 years. A decathlete participates in 10 events. So a lot of these you probably already know. You don't really need to spend time with those. But the few that you don't know, di maybe, tetra, hepta, nona, those you want to make sure you take a look at, get a little more familiar with them. Now, let's say look at some examples. We'll start off by going formula to name. Step 1, identify that you're working with a covalent molecule. Again, if it's not a covalent, the rules are a little bit different. So these are 2 nonmetals, both on the right side of the periodic table, N and O. So this is a covalent molecule. So we're going to use our prefixes. Again, we don't use mono on the first element. So there's just 1 nitrogen. We'll just call that nitrogen, no mono. We do use mono on the second element, so nitrogen monoxide. We call this nitrogen monoxide. 1 nitrogen, 1 oxygen. How about NO2? Pretty much the same story. Identify that you're not working with an ionic. We've got 2 nonmetals as a covalent. Again, we don't use mono on the first element, so we'll just call that one nitrogen. Now we've got 2 oxygens, the prefix for 2. Nitrogen dioxide, 2 oxygen. N2O. All right, we don't use mono on the first element, but we'll use any of the other prefixes. So we've got 2 oxygens this time. Sorry, 2 nitrogens this time. So we'll say dinitrogen, 2 nitrogens, 1 oxygen. Dinitrogen monoxide. Here's a big one, P4O7. Okay, let's find 4. 4 is tetra. So we've got tetraphosphorus. That's 4 phosphorus. tetraphosphorus, and then 7 heptaoxide. Tetraphosphorus heptaoxide. All right, easy enough. Biggest challenge, I think, is making sure that you know the difference between a covalent molecule, 2 nonmetals, and an ionic compound, something that's going to have a metal and a nonmetal. So slow down and make sure you always identify that first. And then, if you have a covalent, add the prefix and basically state what it is that you have. Going the other way, hopefully find this one just as easy, if not easier. Name to formula. Again, I think people generally like this one. You just have to write what you see. So for example, dinitrogen pentoxide, 2 nitrogen, 5 oxygen. We just write what we see. The name pretty much tells us everything there is to know. N2O5. Carbon tetrachloride. Again, we don't use mono on the first element, so if there isn't a prefix, we can assume it's just 1 carbon. Tetra is 4, chloride, so C. Cl4, 4 chlorides, 1 carbon. One more example here. Boron trifluoride. Again, no mono, so that's just 1 boron. Fluoride, and there's 3 of them. BF3, boron trifluoride. So again, the biggest challenge with working with covalents is making sure you're working with the covalent. Identify that you have a covalent, not ionic. And after that, hopefully, with these prefixes, it's pretty straightforward. Hope this helps. I'll be seeing you tomorrow. Take a look at the next lesson. See you then.